In this video, we're going to give you a narration of the discovery trail in the ancient Bristlecone Pine Forest in the Schulman Grove in the White Mountains of California. This grove holds some of the oldest trees alive.
Discovery is the result of a unique combination of curiosity, observation, knowledge, and persistence. Dr. Edmund Schulman was searching this area in 1953 for very old trees in an attempt to uncover the secrets hidden in thousands of years of tree growth. His work soon paid off when he discovered living bristlecone trees over 4,000 years old in now what we call the Discovery Trail. This 1-mile loop trail will take less than an hour to walk. Interpretive panels along the way relate the story of the discovery of the oldest trees in the world, the ancient Bristlecone Pines. Rest benches are located along the trail. Enjoy your walk and see what discoveries you can make on your own. Okay, so this dead one tree died in 1676, according to the marker. And you can see the tree rings that they examined as part of the dendrology. So this tree died over 300 years ago, and it's still not rotted. Life down under, plant evolution in the Great Basin can result in a unique adaptations to an arid environment. Roots of the bristlecone pine grow close to the surface of the soil to capture scarce moisture before it evaporates. The toppled trees near you display these shallow root systems. Root exposure can occur as a result of soil erosion. The average rate of erosion is 1 foot of soil loss per 1,000 years. Some scientists have used this information to estimate the ages of ancient trees by measuring the amount of erosion. Others have suggested that some trees die as a result of diseases associated with these exposed roots. So this is a tree that has a lot of exposed roots, and it also is still growing because it has some bark and has some pine needles, so it's probably pretty old. Appearances can be deceiving. Dr. Schulman began his search for old trees by examining the bristlecones on the north-facing slope directly across the canyon. He studied the giant sequoia trees in the past, and like many of us, he might have thought that larger, taller trees were the older ones. Not so with the ancient bristlecones. In a curious twist of history logic, it is the shorter, weather-beaten, gnarled trees that can live the longest. The dry, exposed south-facing slope that you are standing on leads to slower growth in the bristlecone pines, producing hard, dense, resinous wood. This hardwood is much more resistant to disease and insect penetration, thus promoting longevity. Dr. Schulman was much closer to the discovery of his dream than he knew. His unplanned late afternoon stroll across the canyon changed forever both his life and our understanding of the natural history of the ancient bristlecone pine. Wow, look at this one. You can see how much exposed roots it has, and it's still living. It's still got bark on one side of it, and pine needles and cones. Let's see what it says. Forces of mortality. Soil erosion is a concept most of us are familiar with. Wind, water, and ice are the primary agents of this topographic change. But gravity is also at work, slowly but steadily dragging down the mountains. The exposed roots of the trees in front of you show the effects of thousands of years of erosion. If you can detect the original soil line on the roots, you'll notice that nearly 3 feet of soil has been lost, exposing a great deal of the main root system. Soil loss can eventually destabilize a tree, causing it to topple. This particular tree, however, has caught the eroding soil on the uphill side, creating a gravitational standoff. These exposed roots can be vulnerable to disease and insect infestation. Indeed, some scientists feel that root exposure is the leading cause of mortality for the ancient trees. Pathway of the Ancients. Dr. Schulman has been taking core samples from trees on the other side of this drainage when he ventured into the grove of bristlecones in front of you. He took a core sample from one of the old gnarled trees and headed back to his camp to count the annual growth rings after dinner. In stunned excitement, he had continued counting rings beyond BC 248. He had discovered the first tree in the world known to exceed 4,000 years in age, and it was still living. That 4,000-year-old tree was one of many discoveries that Dr. Schulman was to make in this area. As you walk this next section of the trail past many of these ancient trees, imagine that late night in 1953 when Dr. Schulman kept counting and counting. And you can see many of these trees have a lot of root exposure. A lot of parts of the trees are dead, but a lot of parts of the trees are also alive. Okay, so we're almost to the high point of the trail here, and boy, there are some beautiful old trees, including the one I'm standing by. Ocean bottom red rocks. Much of the White Mountains are made of layers of rock that started as sand, mud, or shells deposited on the bottom of a shallow, warm ocean. The weight of the additional material deposited on top of this sediment compressed some of the sandstone rock. As the ancient seabed was folded and uplifted to form the White Mountains, the rocks were put under great stress and heat. The grains of sandstone were partially melted and fused together through a process called metamorphism. This led to the formation of the red quartzite rock you see along this trail. As the mountains rose, the quartzite was eventually uncovered by erosional forces of wind, rain, and ice. A process called ice wedging is now breaking the quartzite apart as water freezes and expands within the cracks of the rocks. The debris from this process is called a talus slope, through which the Discovery Trail winds. As you hike this portion of the trail, note the intricate rock work that was done by the trail construction crew. Okay, so this is, I think the famous tree behind me is a dead sentinel, which is, it's actually a dead tree because it doesn't have any green parts. It doesn't have any pine needles. It doesn't have any live bark. But it's a beautiful tree, and it's often photographed, and it's often referred to as Methuselah. It obviously is not. If you want to see the actual Methuselah, that's in my other video about the Schulman Grove. It's actually in, surprisingly, the Methuselah Walk, and we're on the Discovery Walk, but this is a beautiful dead tree. Subtle differences is in the genes. After the last ice age ended approximately 10,000 years ago, the bristlecone pine apparently migrated north from its southern ice age retreat. From one common ancestor, 3 closely related species have evolved: Pinus astrea, the Rocky Mountain bristlecone; Pinus balfoura, the foxtail pine of the Sierra Nevada; and Pinus longeva, the Great Basin bristlecone. Although all the bristlecones in this area are the same species, the Great Basin bristlecone, individual trees reveal genetic differences, demonstrating that the species continues to evolve. In front of you are 2 old bristlecone pine trees. The one has a twisted trunk, while the other grows straighter and taller. Behind you are 2 trees which have first-year cones of different colors. The purple cones are most common ones, are a genetic variation. So they want us to look behind us, and they have, and look at the cones of the trees behind us. So this tree next to me, which is right next to Dead Sentinel, it's just Dead Sentinels, there you go. It is still live, so it could be one of the oldest trees living. I don't know. It's hard to say without a core sample. It looks nothing like Methuselah, which has very straight, dead branches. Twisted, gnarled branches are not necessarily a sign of an old tree. White rocks and tough roots. It has been said that bristlecone pines prefer dolomitic soil, where they are found in greatest concentrations. Bristlecone pines don't have a choice in where they grow. They are found in soils with high concentrations of dolomite because few other plants can survive in such alkaline soils. This lack of competition gives them the opportunity to establish strong, viable seedling. In addition, the light-colored dolomite promotes cooler soil temperatures by reflecting heat, thereby making more water available to the trees by reducing evaporation of moisture from the soil. Notice the hillside in front of you. To the east of the drainage is the familiar white-colored dolomite supporting a grove of bristlecones. The soil west of the drainage supports many other species of plants which grow faster than the bristlecones and thereby outcompete them for scarce nutrients and water. As plants continue to invade the rocky slope to your left, their roots will slowly break apart the rocks to create life-supporting soil. Right, so this is the better soil area, and then you look at the dolomite area and there's no other competition to the bristlecones because they're the only ones that can survive. Better soil, worse soil. Dr. Edmund P Schulman. In 1953, Dr. Edmund P Schulman was searching this grove within the bristlecones for old trees to extend his tree ring chronology. With his discovery of the pine alpha tree, he became the first person in the world to document 4,000-year-old trees. He continued his persistent search and in 1957 discovered the oldest living tree in the world, the Methuselah tree. This ancient is located in the Methuselah Grove, a 4-mile round-trip hike from here. The significance of Dr. Schulman's discovery can scarcely be overstated. The continuous bristlecone tree ring chronology, including living and dead wood, now extends back nearly 10,000 years. Data from these tree rings support important scientific research on radiocarbon dating, past climates, air quality, frequency of fires, and water supply trends. Although Dr. Schulman died at the age of 49 in 1958, his legacy of discovery is still with us today. Okay, so that's the end of the Discovery Trail. Subscribe to Slowboat Sailing, where we give you the secrets of the greatest trees around.